5.4, we're going to factor and solve polynomial equations. This is going to start off with stuff that we've already done in the past, then we're going to learn some new techniques also. Remember, when you're factoring, just because something's in parentheses does not mean that you factored it completely. You've got to keep going if possible. So we'll see that and quite a bit more in today's lesson. It says factor the polynomial completely, and then I forgot to put the polynomials there. So see if I can wave a wand and make them appear. There we go. If you don't remember how to factor quadratics, go back and study those lessons again. I prefer the method of Clinton magic. One thing you might remember from some of the harder problems is we have to look for a common factor first. And all three of these have a common factor. In this case, on the first one, I see an x, and what's left is x squared plus 2x minus 15. Then we can try to factor the inside using Clinton magic. Go ahead and pause the video and try that on your own. Also, go ahead and try parts B and C on your own. See if you get the same answers as me. This is all review right here. I left out the in-between steps because I expect you to be able to do those on your own. They'd be part of your work. We're going to learn two new techniques of factoring, sum and difference of cubes. We already know a formula for difference of squares. That's a nice one. These two new formulas are a little bit more convoluted and scary looking. You do have to memorize them. One thing I can say that might help you remember them easier is both of the formulas have a single minus sign in them. And the one that starts with a plus, in between, the first sign is a plus. The one that starts with a minus, the first sign is a minus. So that might help you remember where to put that minus sign. Other than that, the two formulas are exactly the same. And I'll repeat what I said, you do have to have them memorized. So we look for a sum of cubes. The clue that this is a sum of cubes is we've got something cubed. Try to figure out what you're cubing on both pieces. And once you've done that, try the formula. Pause the video and try that on your own. Assuming you factor out the common factor before you start, in this case there wasn't one, but as long as you do that, nothing else is going to be factorable after you apply the difference or sum of cubes formulas. I rewrote the formula up here. Notice in the purple, I changed the minus in the original problem and showed you where to put the plus and the minus in the new one. You just have to know those formulas. Part B is a little tougher because I don't know what to cube to get 16 or to get z to the 5th. That's why you have to check for that common factor first. So pull out the common factor, pause the video, try that, check in with me before we go to the last step. At this point, you should be able to look at the 8z cubed and say, oh, that's something cubed. And the 125 and say, oh, that's something cubed. And don't forget to put your 2z squared on the outside in your final answer. Try this on your own. Notice I highlighted the 4 in my final answer. A lot of people forget to put the 4 there. They'll put 2z squared. You're really doing 2z squared times 2z times 2z, which is 4z squared, not 2z squared. Other than that, this is just an application of the formula. At this point, you can pause the video and try these on your own, or you can do that later. Next up is factoring by grouping. You might remember factoring by grouping from Algebra 1. We'll use that technique whenever we see 4 terms to factor. We write this in standard form and then say, okay, what can I take out of the first 2? I see that I can take out an x squared from the first 2. Then I say, what can I take out of the second one? Looks like I can take out a minus 16. Don't forget to apply your distributive sign. Negative 16 times negative 3 is positive 48. Because these parentheses match up, that means that my factoring by grouping worked. If this didn't match up, factoring by grouping wouldn't work, and we'd have to try something else. We don't know how to try anything else yet, so we'd be stuck. Next, I just get to write my x minus 3 because it was in both of those. And say what's left? X squared minus 16. And if you stop there, you made a mistake. X squared minus 16 can be factored. It's a difference of squares. Don't forget our x minus 3 in front. And we've got everything we can do on factoring this. Wouldn't it be fun if this whole thing said equals 0 and then we had to solve for x? We should do that soon. Okay, next up. These are a couple special cases, part A and part B. We're going to look at part A. I see two terms. Normally when I see two terms, I think difference of squares. But 16x to the fourth isn't really a square necessarily in our minds. But it turns out it actually is. Because what can you square to get both of these? If there is something, then difference of squares works. We square 4x squared, and we square 9. So we can use our difference of squares formula. And we got to be careful. We could try to factor this further. 4x squared plus 9, we can't do anything to. That's a sum of squares, not factorable. 4x squared minus 9, that's a difference of squares again. 2x plus 3, 2x minus 3. And don't forget our 4x squared plus 9. Now we're factored completely. We could actually factor that 4x squared plus 9 using some pre-cal techniques. It would involve imaginary numbers, but we're not going to worry about that right now. Next up, this one's actually pretty hard compared to some stuff that we've seen. You might first guess to factor out that common factor, and you'd be right. Try to look at that and see if you can come up with what the common factor is. If you saw 2, good job. If you also saw a p squared, great job. Then look at what's left. This kind of looks like something you'd use Clinton magic on, except the exponents look too big. So this is called quadratic form. It's not really a quadratic, but it acts like a quadratic when we're factoring. In place of p cubed, I could write something like an a, which means p to the 6 would be a squared. So I'm making a little substitution to make the problem easier. A squared plus 10a plus 6. I made a mistake. That shouldn't be a 10. If you already caught that mistake and you're getting ready to call me out on it, good job. Should be a 5. This we do know how to factor. A squared plus 5a plus 6. A plus 3, a plus 2. And we don't want to forget our 2p squared on the outside. This is almost done. This is totally factored. The only thing left to do is to say, wait, we're not supposed to have an a in our answer. We're only allowed to have the letter p. So we go back and rewrite it. 2p squared, p cubed plus 3, p cubed plus 2. And both of those parentheses can't factor because they look like they might be a sum of cubes, but we don't know what to cube to get 3. We don't know what to cube to get 2. So we stop here. So I think that's pretty hard. Part B, again, there's a special name for that. It's called quadratic form. And it's always the type of problem people love to miss on the quiz or test, especially in higher level math. At this point, you can pause the video, try these on your own, or you can do that later. Next up, we want the real number solutions of the equation. I'm going to have you try this totally on your own. The one hint I'll give is make one side equal to 0. Go ahead and pause the video, try this on your own. If you're having trouble, your factoring should look like this. So see if you can get this. Once you're here, try to get your answers. I actually didn't finish factoring all the way. Could also factor the difference of squares. X squared minus 5 doesn't factor because 5 is not a perfect square. But we get our answers. X equals 0, plus or minus 5, negative 1, or positive 1. So we look for that answer choice, which actually be square root of 5. If you're not sure how to get to here, set up a little equation. X squared minus 5 equals 0. And you'll eventually get there. And it looks like we have our answer choice. At this point, you can try these on your own or do them later. Okay, last problem is a word problem. Pause the video, see if you can come up with the equation. The one hint I will give is volume equals length times width times height. You'll have to use that formula twice in this problem. It's kind of a tough one. Hopefully you were able to set up the volume formula for the entire marble basin. That would be, not counting the empty hole in the middle, we'd go 2x times x, which is 2x cubed. The hole in the middle is a little harder. We've got to subtract a foot. We don't want 2x for that entire length. It's 2x minus that little width, and that width shows up twice. So the 2x becomes 2x minus 2. Next, we look at this side. It also has that 1 foot width that has to be cut out on each side. So we say x minus 2. And last up, we don't have that width on top and bottom, it's just on bottom. So instead of x minus 2, we say x minus 1. Now we can multiply all that stuff together using the techniques from the previous lesson. Go ahead and pause the video, see if you get the same thing I do. And we get that entire volume. And we can remind ourselves that's supposed to be the volume of the inner part of the basin. It also tells us that that volume is supposed to be 36 cubic feet. So we can say this whole thing equals 36. What's left now is to solve for x. And to do that, we need to set this whole thing equal to 0. Once you do that, hopefully it'll make your life easier by noticing that something can be divided out of this whole thing. I can divide the whole problem by 2 to get easier numbers. Now we just need to solve for x. And to do that, require some factoring by grouping. Go ahead and try that on your own. Pause the video. Solve for x. Once you've gone through all that, you get 3 possible answers for x. Positive I root 5, negative I root 5, or positive 4. Since this is a real-world dimension, the only answer that makes sense is x equals 4. So now that we know this was a 2x by x basin, we can say x is supposed to be 4. That makes this an 8 foot. I believe it was feet. Yes. By 4 feet by 4 feet. And we've got our solution. It's kind of tough. It requires some factoring. It requires some thinking to set up that equation. It also requires you to know the volume formula for a cylinder, which I won't make you memorize. At this point, you can try one of these on your own, or you can do that later. Other than that, we're done with this one. Another long one. Hopefully you got through it okay.